Hello friends, this question is from the subject of network in the topic of transient state RLC circuits. It's a 2 marks question. In the problem we need to calculate the voltage across the inductor and the current across the capacitor. So let's draw the diagram of the circuit, steady state diagram of circuit at t is equal to 0 minus. So at t is equal to 0 minus, my knob will be connected to the supply voltage 10 volt. At that time my steady state circuit will be 2 ohm resistor will be comes in a picture. My inductor will be short circuited. At that time current IL will be flowing across it. Two ohm resistor in parallel with a capacitor which will be open circuited. So we have a effective loop this in which we have a two ohm resistors and one 10 ohm batteries. And my IL 0 minus will be equal to 10 upon 4, which is 2.5 ampere. 2.5 ampere current will be flowing here and the voltage across this 2 ohm resistor will be 2.5 into 2, which is 5 ohm, 5 volt, because it is 2.5 into 2 is equal to 5 volt. So my capacitor will be charged, VC0 minus will be 5 volt. So now at t is equal to 0, when my knob will be switched from 2 ohm to this capacitor 2 farad, then my new effective circuit will be, by this 2 farad capacitor, this capacitor is initially discharged. So voltage across this capacitor will be, name it VC1, will be 0. And we know that capacitor oppose the sudden change of voltage and inductor oppose the sudden change of current. So at t is equal to 0 plus, if I again redraw the steady state diagram, then my this capacitor, 2 farad capacitor, this one which I have named at BC dash, will be replaced with a short circuit because it is initially 0. My inductor will be replaced by a current source of 2.5 ampere, because IL will be same as the previous. There is 2 ohm resistor parallel with a capacitor with a battery source of 5 volt. Because my earlier this capacitor will be charged, this capacitor will be charged with a source current. Source current will charge with the polarity of plus and minus. Capacitor retain its polarity because it opposes a certain change of voltage. That's why the polarity of the battery is plus and minus. So now question says find out the voltage across the inductor and current across the capacitor. Now you can see that here in the diagram, this 2 ohm resistor is connected with a parallel with a 5 volt battery. So voltage across this 2 ohm resistor will be 5 volt. So current across this 2 ohm resistor will be 5 volt divided by 2 ohm, which is 2.5 ampere. Because current I is nothing but a V by R. So current across this 2 ohm resistor is 2.5 ampere. So if you can see, if you can look at this node A, name it A. So at node A is incoming current is 2.5 ampere, outgoing current is 2.5 ampere. So in this capacitor branch, which will behave like a battery right now, the current across this capacitor will be 0, because my incoming current is already equal to the outgoing. So current across this capacitor will be equal to 0. So there will be no current will going to flow across the capacitor. Similarly, you can see that my this current source is basically an inductor, because my inductor Vx inductor is 200 inductor is replaced by a current source here. So this current source is my current source is basically is my inductor, which is, you can see that, if you can see, you can take a look of the node A. So in node A we have 3 parallel branches, one current source, one 2 ohm resistor, one 5 volt. All these 3 branches are in parallel. You can see that my my current source is in parallel with a 5 volt battery, and in parallel we have a fundamental law. KVL says that in parallel voltages are same. So current source across the inductor, voltage across the inductor will be 5 volt because it's in parallel with the battery. So the voltage source across the inductor is parallel, or you can say that Vx0 plus will be 5 volt and IC0 minus IC0 minus 0 plus IC0 plus will be 0 volt because there will be no current there is no current which is going to flow across the capacitor. So I have my voltage across the inductor is 5 volt and current across the capacitor is 0 ampere. So my right option is option B. Option B is my correct option. B is my correct option. Thank you.